Hello everyone. In this video let us discuss some problems related to condensed matter physics. In that the first one, NaCl has FCC lattice with A equal to 5.63 angstrom units. The spacing of 100 planes is. Interplanar spacing for lattice planes for FCC lattice for 100 plane is A by 2. Now A is given as 5.63 angstrom units. So D100 is equal to 5.63 by 2, 2.82. How the crystal structure of diamond formed? It is formed by carbon atoms. It consists of two interpenetrating FCC lattice which are displaced along the body diagonal of cubic cell by 1/4 diagonal length. So it has two atom bases of 0, 0, 0 and A by 4 I plus J plus K. Now next, he is asking to find the packing fraction of diamond structure. Now for diamond structure R equal to root 3 A by 8. Okay. Now the packing fraction formula is volume of atoms by volume of unit cell. At each corner 8 atoms are there. So the volume of atoms is 8 of 4 by 3 pi r cube volume of atoms divided by volume of cell A into A into A cube. Right? So R equal to root 3 A by 8. You substitute. Now after 8 into 4 by 3 pi root 3 A by 8 whole cube into 1 by A cube. If you simplify, you will get root 3 pi by 16. Okay. The packing fraction is root 3 pi by 16. Now next, gold has atomic weight 197, density 19.3 gram per cc. Spacing between atoms in solid state. Spacing formula A by 2. Atomic weight 197, density 19.3 gram per cc. Avogadro number 6.02 into 10 to the power of 23. Since solid gold has FCC structure, so that number of molecules per unit cell is equal to 4. That is equal to n, say. We know that A cube equal to n m by rho n. That is equal to, substitute the values 4 into 197 by 19.3 into 6.02 into 10 to the power of 23. You will get A equal to 5.14 into 10 to the power of minus 8 centimeter. So spacing A by 2, no, 5.14 by 2, that is equal to 2.57 angstrom units. Now next question, how many atoms are there in a HCP structure? Right? The formula is actually NC by 8 plus NC by NF by 2 plus NB. Here NC is number of atoms at corners. 12 corners are there, shared by each atom shared by 6 unit cells. So 12 into 1 by 6, 2 atoms. NF means number of atoms of FCC. 2 atoms on top and bottom faces and each atom shared by 2 unit cells, 2 into 1 by 2, 1 atom. NB means atoms in BCC. Within the body 3 atoms are there. So 3 plus 1 plus 2, 6. Atoms per unit cell in HCP structure is 6. Now next, how many atoms per unit cell are in FCC structure? In FCC structure, corner 8, face centered 6, body centered 0. 8 by 8, the formula we are applying. NC by 8 plus NF by 2 plus NB. 8 by 8 plus 6 by 2 plus 0 equal to 4. Right? Now next, 7 crystal system we discussed in part 1 video. Once check it. Now next, the packing fraction of SC lattice as compared to FCC lattice. First, packing fraction of SC lattice, simple cubic lattice, let us find out volume of atoms by volume of cell. Simple cube, number of atoms 1. Atomic radius A by 2. Lattice parameter A. So packing fraction, number of atoms, how many? 1. 1 into volume is 4 by 3 pi r cube by volume of cell A cube. So substitute r equal to A by 2. Simplify, you will get pi by 6. Similarly, next let us find out the number of atoms in FCC cell 4, atomic radius A by 2 root 2. So this atomic radius, density, coordination number in part 1 video I wrote in a box, once go through it. So now substituting the values, 4 into number of atoms 4, no, 4 into 4 by 3 volume pi r cube by A cube. Now in place of r, A by 2 root 2. Now if you substitute and simplify, you will get root 2 by 6 pi. So the packing fraction of FCC is greater than SC. Now next, germanium and silicon have diamond structures for which molecules per unit cell are equal to. Diamond is FCC structure with basis of 2 atoms. And in this structure, each atom has 4 nearest neighbors. So 1 by 8 into 8 plus 1 by 2 into 6 plus 4 equal to 0. Our formula, NC by 8 plus NF by 2 plus NB, that formula we used. The angle of reflection of neutron beam from a crystal of interplanar spacing 3.84 angstrom unit is 30 degrees. The speed of neutron will be. Now we are applying Bragg's condition, 2d sin theta equal to n lambda. D he gave as 3.84, theta 30 degrees he said. So 2 into 3.84 sin 30 equal to lambda. So lambda value h by mv, de Broglie wavelength. So v equal to h by m lambda. That is equal to h, the Planck's constant, 6.62 into 10 to the power of minus 34 divided by m, 1.67 into 10 to the power of minus 27 for neutron mass, into lambda we find it as 3.84 10 to the power of minus 8. Now simplify, you will get 1.03 into 10 to the power of 5 centimeter per second. Now next, the translation vectors of space lattice are A x by 2 plus root 3 by 2y, B minus 1 by 2x plus root 3 by 2y, C equal to Z he given. He is asking to find the volume of cell. The formula is A dot B cross C. Right. Now first B cross C let us write. X, Y, Z. B value minus 1 by 2x plus root 3 by 2y. So minus 1 by 2 root 3 by 2 0. Now C value Z he said. So X component 0, Y 0, Z 1. Now next X. So B here I am writing plus root 3 by 2y he gave. C he said to take as Z. Okay. Z only no. C is equal to Z. Now we substituted the values. Now we did the determinant X. Row and arrow you take root 3 by 2 into 1 minus 0 into 0 0. Minus Y. Row column if you take minus 1 by 2 into 1 minus 1 by 2 minus 0. Plus Z. 0 into something 0, 0 into something 0. So what you will get? Root 3 by 2x plus 1 by 2 y minus minus plus. So A dot B cross C he said. What is A? X by 2 plus root 3 by 2 y dot. Now this is B cross C. Now dot product x dot x. What you will get? 1 by 2 into root 3 by 2 plus y dot y. Root 3 by 2 into 1 by 2. So if you simplify, you will get root 3 by 2. Okay. Now next question. In a closed packed crystal structure, the percentage of available volume occupied by hard spheres is. Closed packed crystal structure. The percentage of available volume occupied by hard spheres. The available volume occupied by hard spheres is V by V into 100, where small v, volume of atoms in the cell, pi a cube, volume of unit cell, capital V, 3 by 2 root 3 a square c. Now volume occupied by hard sphere, volume of atoms in cell by volume of atoms in unit cell into 100. You simplify, you will get 2 pi by 3 root 3 a by c into 100. But we know the value of c by a as 8 by 3 under root. So now here we want a by c. So a by c equal to 3 by 8 under root. You substitute a by c value here. Okay. Now next, if you simplify, you will get 74%. Now next, packing factor or density of packing in case of base body centered cubic cell. For BCC, V by V. Volume of atoms by volume of unit cells. Volume of atoms, 2 atoms will be there in BCC, 2 of 4 by 3 pi r cube by volume of cells A cube. You just simplify, R value is root 3 by 4 into A. Right? So substituting that, you will get 68%. Now next, atomic radius in case of FCC. I am taking one particular unit cell and its cross section area. C. He is asking to find the atomic radius. Here to here 2r, r, so it becomes 4r. Now let this be spacing A, this be A. Now B square equal to Pythagoras theorem. DC square plus BC square. That is 4r whole square equal to A square plus A square minus 2A square. Right? So 4r is equal to, one second. So 4r whole square equal to A square plus A square 2A square. So 4r equal to root 2A, r equal to root 2 by 4 into E. Which of the following statement is correct? 4 he gave, this is the correct statement. Volume of unit cell. For cubic system, A equal to B equal to C. Hence volume of all three forms, simple cube, base centered, face centered, are equal. So V equal to A cube, VSC equal to VBCC equal to VFCC is correct. Coordination of FCC. 4 into 3, 12. So 4 close neighbors are in each 3 planes here. Now magnesium crystallizes in HCP structure. The lattice constant is 0.32 nanometer. The nearest neighbor distance 2 are equal to A. So A 0.32 nanometer. So 0.32 nanometer is the nearest distance. The nearest neighbor is 2R. That value will be equal to A. So that is the answer. Packing factor of diamond. Formula. Volume of atoms by volume of cell. In diamond, 8 atoms are there. 8 of 4 by 3 pi r cube by A cube. So R value root 3 A by 8. Substitute, you will get 34%. Now metallic iron changes from BCC to FCC structure at 9-10 degrees Celsius. With an increase in atomic radii, the density of iron. We know A cube equal to Nm by rho n. Rho equal to Nm by A cube n. Rho is proportional to 1 by A cube. Right? So, the density is proportional to lattice parameters and hence atomic radius. Atomic radius of BCC A root 3 by 4, FCC root 2 A by 4. You have to memorize this. So radius for BCC is greater than radius of FCC. Okay, comparing these two values. So density increases. Okay. Now next question. In simple cubic lattice, D100 is to D110 is to D111 is D formula A by under root H square plus K square L square. For D110, H equal to 1, K equal to 0, L equal to 0. Substitute. You will get A by root 1. Similarly, 110, you substitute. You will get A by root 2. 111, you substitute. You will get A by root 3. Now the ratio A by root 1 is to A by root 2 is to A by root 3. LCM is root 6. So root 6 is 2. Root 3 is 2 or root 2. Actually LCM is root 6. So root 1 into 6, root 6. So A root 6 we will get. Here A root 2, how many stars are 6? 2 3s are 6. A root 3 we will get. 3 2s are 6. A root 2 we will get. A common it will go. Root 6 is to root 3 is to root 2. Right? So next step. one of the important model problem. Here first let us go for this. The number of atoms per unit area of the plane 0, 1, 0 of a simple cubic crystal he is asking. Now here first 0, 1, 0 means x component 0, z component 0, y component we are having. This is the structure. Here A will be equal to 2r. A lattice constant in millimeter, r radius in millimeter, area A square, so square millimeter contains 1 atom. So 1 square millimeter contains 1 by A square, 1 by 4 r square atoms. Now for 1, 1, 0 plane. So now here 1 is x, y, z. So here A becomes 2r and this distance is root 2a. So area of plane root 2a into a, root 2a square. Atom per square mm is 1 by root 2a square. That is equal to 1 by root 2 into 1 by 4r square. That is equal to 1 by 4 root 2 r square. Okay. So 1 by a square value is 1 by 4r square. We substituted here. 1 by a square equal to 1 by 4 r square. Now similarly for 1, 1 plane. X, Y, Z 1, 1, 1. Now here the distance is a root 2. Angles are 60. So atoms per square millimeter 1 by 2 by root 3 by 2 a square. Area is root 3 by 2 a square. Number of atoms 1 by 6 into 3. It is surrounded by 3 atoms 1 by 2. 6 atoms. 3 are surrounded by 6 atoms 1 by 2. Substituting 1 by 2 divided by root 3 by 2 a square, we will get 1 by root 3, 1 by 4 r square. Now next, the total energy of ionic solid is U equal to minus alpha E square by 4 pi epsilon naught r plus B by A. Alpha made long constant, r distance between the nearest neighbors, r not equilibrium separation. Then constant B is given by B value we have to find out. So U equal to minus alpha E square by 4 pi epsilon naught r plus B by r to the power of A he gave. It is equilibrium separation r naught for equilibrium separation r naught. Minimum energy du by dr at r equal to r naught equal to 0. Let us differentiate this. D by dr minus alpha E square by 4 pi epsilon naught r plus B by r to the power of 9. Differentiation of here in this is constant, this is constant, 1 by r only. Differentiation of 1 by r minus 1 by r square plus B d by dr 1 by r to the power of 9. Differentiation of 1 by r to the power of 9 will be minus 9 by r to the power of 10. But at r equal to r naught du by dr equal to 0. In place of r you substitute r naught, that is equal to 0. So 9b by r to the power of 10 equal to alpha E square by 4 pi epsilon naught r naught square. We want B. So alpha E square by 36 pi epsilon naught r naught e to the power r naught to the power of 8 we will get. Now next, the relation gives the potential energy of diatomic molecule is this, you memorize, most important, minus a by r to the power of m plus b by r to the power of n. Derivation of that. So potential energy of diatomic molecule, most important relation, minus a by r to the power of m plus b by r to the power of n. Okay. Now a value a by m minus 1, b value b by n minus 1. Okay. So now here, next question, the lattice energy per kilomole of NaCl crystal. Okay. So remember this formula sum, Coulomb's potential energy minus a E square by 4 pi epsilon naught r, most important relation. Bond's repulsive potential UR equal to B by R to the power of N. Total energy UR plus UC, we substituted UR and UC and we simplified. Now the lattice energy we will get as, most important relation, please remember it, minus a E square by 4 pi epsilon naught r naught 1 minus 1 by n, minus a E square by 4 pi epsilon naught r naught 1 minus 1 by n. So what are the important? 1. The potential energy of diatomic molecule minus a by r to the power of m plus b by r to the power of n. Coulomb's potential energy minus A E square by 4 pi epsilon naught r. Bond repulsive potential U r equal to B by r to the power of n. And this particular lattice energy minus A E square by 4 pi epsilon naught r naught 1 minus 1 by n. Okay. Now next, the radii of cesium and calcium are R1, R2. The lattice constant if it crystallizes in BCC structure. Now this we took a unit. So Fc square is equal to, now this triangle I took a diagonal, a unit cell, Fc square equal to AC square plus Fa square. But here AC square, again this you take, no, AC square equal to CE square plus AE square. Now A square plus A square, 2A square. Fc square equal to 2A square plus A square. Now AC square is 2A square. FA, where is FA? Is A. So 2A square plus A square, 3A square. Fc equal to 2 R2 plus R1 plus R1 whole square equal to 3A square. The value of Fc 2 R2 plus R1 plus R1. So 2 R2 plus R1 plus R2 whole square equal to 3A square. Now 2 common if we take R2 plus R1, this is R2, root 3A. So A equal to 2 R2 plus R1 by root 3. A two-dimensional lattice has basic vector A 2x, B x plus 2y. Then reciprocal lattice. Let C equal to Z. Reciprocal lattice B cross C by A dot B cross C. First do B cross C. Okay, I am giving you the idea. First do B cross C. That is, what is B? X plus 2y cross C Z. Now you will get minus y plus 2x. Then you do C cross A. What is C? Z cross 2x. So using this vector product rules, this will be 2. Z cross x means y. Right? We will get y. Now A dot B cross C you do. Okay. A, what is the value of A? 2x means 2, 0, 0. B, what is the value of B? 1, 2, 0. What is the value of C? Z, he said 0, 0, 1. Now do the cross product. You will get minus y plus 2x by 4. That is half x minus y by 2. Or B equal to 2y by 4. That is equal to y by 2 we will get. Okay. Now next, the ratio of volume of atoms to the total volume of available in a simple cubic lattice. V by V formula. Simple cube, no. Only one atom will be there. 4 by 3 pi r cube by a cube. R means a by 2. Simple cube. Simplify, you will get 52%. Now next. The Bragg's angle for the order of reflection 111 is 30 degrees. Wavelength 1.75. Formula 2d sin theta equal to n lambda, n equal to first order he said 1. Lambda equal to 1.75, theta equal to 30. You substitute, you will get d as 1.75 angstrom units. He asked to find interatomic spacing. D equal to a by under root h square plus k square plus l square. H equal to 1, k equal to 1, l equal to 1. You substitute, you will get a equal to root 3d. Now d here 1.75, substitute 3.031 angstrom unit you will get. Okay. Now next, in powdered method pattern for lead with radiations of lambda equal to 1.54 angstrom units, 220 Bragg's reflection angle at theta equal to 32 degrees, the radius of atom will be. So crystal structure for lead is FCC. So R equal to root 2 A by 4. For 220, D equal to this formula. 2 square plus 2 square plus 0. A by root 8. So A equal to root 8 into D. R equal to root 2 into root 8 by 4 into D. That is equal to root 2 into 8 D by 4. So R equal to D. So thank you for watching my video. If you like my video, share it, subscribe it.